Hello everyone, I'm Tang Ying from China Mobile Zhejiang. I'm so glad that I have this opportunity to share with you China Mobile Zhejiang's thoughts and practices with regard to the 5G C-O-N-M. 4G changes lives, while 5G changes society. 5G is not a simple combination of 4G and 1G. It will be more revolutionary and present higher value. It provides infrastructure support for the cross-domain and multi-layer comprehensive in-depth industry integration, and maximizes the impact of amplification on economic and social development using digital applications. To avail itself of the opportunity of 5G industry development, China Mobile Zhejiang proactively promotes the construction of 5G SA networks across Zhejiang province. On the 2C network, more than 38,000 5G base stations have been deployed. The road test coverage rate in urban areas reaches 99.57%. There are more than 8 million 5G UEs, and the number of active SA users exceeds 3 million. In terms of 2B construction, 13 flagship corporate projects and 240 provincial projects have been initiated. 5 demonstration bases have been built, and more than 400 innovative application achievements have been accomplished. While expanding service boundaries and facilitating digital transformation of various industries, 5G also brings new challenges to the entire process of network planning, construction, maintenance, optimization, and operation. For example, in the core network field, a large number of network design parameters needs to be configured manually. The vertical and horizontal deployment of cloud-based networks is time-consuming, and manual operations are complex. There are a large number of edge sites, and the deployment of maintenance workload can be stressful. It is difficult to troubleshoot faults by layer or across layers. In the wireless field, site planning can be quite difficult. Multiple ITs need to be planned in a centralized manner. A large number of base station parameters need to be configured. As a result, the efficiency of manual configuration is low. In the transport network field, the problems such as complicated link configuration and long service provisioning time need to be resolved urgently. In addition, the emergence of 5G slicing technology poses new requirements on the service rollout speed and 2B O&M. We are in urgent need of a brand new mechanism to ensure efficient network O&M and service provisioning. China Mobile Zhejiang, as a pilot site, takes the lead in building 5 capability centers for the next generation OSS. The capability centers include orchestration center, performance center, fault center, resource center, and collection center. Today, I'd like to tell you something about the fault center. We cooperate with Huawei to build a fault center featuring fast detection, accurate demarcation, and rapid resource smooth construction of 5G C fault management and maintenance capabilities. This ensures the optimal network access experience for over 100 million users. The fault center is based on the cloudified and microservice. The fault center also introduces the intelligent machine learning platform to collaborate with the fault application layer. By doing so, we can build an intelligent fault management system, push forward to the evolution of autonomous driving fault management from level 2 to level 3, build flexible orchestration capabilities, and implement quick construction of fault handling capabilities and the transformation of AIOps personnel. Next, I will introduce some specific practices. First, let's have a look at the proactive prevention practices against core network faults. As we all know, there are many types of core network NEs, and their networking is complex. New services brought by 5G are emerging one after another, and O&M becomes increasingly difficult. In addition, core network NEs have a large capacity. Once an accident occurs, at least 1 million users will be affected, causing a large number of complaints and significantly affecting the brand image and customer satisfaction. China Mobile Zhejiang cooperates with Huawei to introduce the two capabilities of core network KPI abnormal detection and machine-assisted network change detection. The algorithm automatically learns the historical data of more than 1,000 KPIs and establishes a KPI self-calibration model to implement automatically inference of the KPI development trend. This feature helps customers detect abnormal KPI in advance, identify network subhealth risks, and detect problems before KPIs deteriorate. As a result, it can provide valuable time for troubleshooting and promoting the transformation from traditional passive maintenance to proactive prevention. Compared with the traditional mode, the core network KPI anomaly detection feature can monitor more than 100,000 KPIs and detect anomalies several hours in advance. The accuracy rate is higher than 85%. Now I'd like to introduce to you the practice of the Unlively cross-layer fault detection on the core network. After the cloudification and decoupling on the core network, the number of detection points increases dramatically. Cross-layer problems involve cross-IT/CT domain, problem locating, analysis, and handling. Cross-layer problems involve cross-IT/CT domain problem locating, analysis, and handling. This greatly increases the difficulty and complexity so that the problem handling and fault recovery takes longer time. In additional mode, the fault detection depends on the experience of experts, and the O&M operations rely on manual check. This mode can no longer meet the O&M requirements in Unlively scenarios. Cross-layer fault detection on the core network has become one of the most serious problems and one of the most urgent tasks for the fault center to resolve. China Mobile Zhejiang works with Huawei to build an efficient Unlively cross-layer detection system. By sorting out typical fault modes of Unlively cross-layer detection, China Mobile Zhejiang forms the corresponding flow of diagnosis rules. Information regarding performance, alarms, traffic, and logs is collected in a centralized manner. The raw data is analyzed and processed to generate O&M events. Auxiliary analysis and detection of Unlively cross-layer problems are implemented through policy design, automatic policy analysis, and policy automation, shortening the cross-layer problem handling duration. It is verified that this solution can demarcate a fault within 15 minutes and automatically recommends handling methods to standardize the O&M experience. Finally, I will introduce our exploration in 5G horizontal fault detection. In this scenario, we introduce the knowledge graph technology. Knowledge graph can help us to solve some problems that cannot be solved by traditional fault trees. For example, the traditional fault tree does not introduce the concept of fault objects, when correlating abnormal events, which is not accurate. However, the knowledge graph constructs the relationship between abnormal events and the objects where the events occur. Diagnosis is based on the relationship between objects. We build the knowledge graph platform to extract, model, integrate, and calculate maintenance knowledge, and form a 5G CONM knowledge graph based on the experience of experts. With the help of the 5G CONM knowledge graph and modeling, the root cause of the fault can be deduced. Let's have a look at the fault propagation chain in the lower right corner. Through analysis, you can clearly feel the cause of the fault. In addition, you can drill down to feel the detailed information. That's all for my sharing. China Mobile Zhejiang will continue to explore the O&M transformation in the spirit of try first. Thank you.